Hi guys, so I'm going to demonstrate how to use XBeach. So we will be using this particular version called XBeach G, which is a very light Windows version that you can download and install easily. So if you Google or search for XBeach G, you would get a first link which will redirect you to this web page of the XBeach software. Now, I would recommend that you go through the whole website of XBeach starting from home so that you get a complete idea about what this software is and what are its applications. And once you go through all of these pages, then go to download XBeach G. Here also you can read a lot of things about the model when it was developed and some applications that you can read from some of the articles. So I would highly recommend you to go through all of these papers because you would need to cite them or refer to them when you write any report or thesis. Now to download the model, you just download the executable which is available here. So if you click on it, it will show it is downloading xbeach.msi. And to install it, you just simply click on it, it would automatically install. Or it may ask you for the directory where you want to install the software. Now, I already have the software installed. So if I search for XBeach G on my computer, you would see I already have XBeach G installed and it is already running. And this is the home page or the welcome page for the model. Now we are going to start with a new model and it is a 1D model. We are not going to do any 2D. So now we have created a 1D model and I would like to first save this model before we run anything or change anything. So I'm going to save and it would open the location where I want to save. I'm creating a new folder XBeach in my documents and I'm going to name this test1 and save. Now the model has been saved. And here you would see the inputs. In inputs, the first thing is if you double click on profile, you would see our beach profile. So you would see from the left hand, there is ocean part and moving to the right, we are moving to the land. Now, in this case, the depth has been limited to 12 meters and this is the continental shelf slope or the ocean bottom slope until we get to the beach. And this is the beach slope and this is the crest and again we have some back slope. So this is the land surface, land elevation that we are going to look at initially. And the grid size is the resolution of the model. So you can see here there are some dots. So imagine these dots are the nodes and the distance between these nodes is the grid size. And for now we are going to leave this with the default values, but you can change this to be, let's say, 10 meters to be the minimum grid size and maximum also 10 meters, or minimum and maximum you can keep 1 meter both, or you can just leave it as it is for now. And here you can modify the beach profile. So you see the offshore depth is defined as 12 meters and the land level is at 0 meters. And the beach slope and the back slope behind the beach are defined here. So these are the parameters that you can change to change the bathymetry or the ocean floor configuration. Now, once we define the bathymetry or the ocean floor, the next thing is we are going to define the wave conditions. Now, for this case, I would like you to only focus on the wave height, which is represented by HS, and the wave period, which is represented by TP. So these are the only two parameters which you should be concerned about for now. And you can change these parameters to see how that might impact the water levels on the beach. We can also include tide in the simulations. For example, if you don't want to include any tide and you just want to keep the water level as mean sea level, then you can remove all of these readings. Or if you want to have some tide level where the water is going up and down along with the wave conditions, then you can define this tide. And then there are some numerical parameters that we need to consider. Uh, the only thing that you need to be aware of is the duration. So how long do you want the simulation to run for? So for example, if I'm at a beach looking at the waves and I'm looking at the waves for 30 minutes straight, and I want to model the 30 minutes, or if I'm standing at the beach for 1 hour and I'm recording the wave height that reaches the beach, and I want to model this 1 hour of waves, then my duration, I would set it to 3600 seconds, which is 1 hour. And the output time step, I would recommend that you maintain it as 0.1. Now that's all. So now you have your model configured and ready to run. So let us try to run this model and see how long it takes to run the model. Now you need to keep in mind the duration that we define here is the wave conditions. So the wave conditions we want to be input for 1 hour. It is not the time required to run the simulation. So if I run the simulation, it might finish in 5 seconds, 10 seconds, or within a few minutes. But within those few minutes, the model is actually simulating waves corresponding to 1 hour duration. So that you need to keep in mind. Now I'm going to run current and see if the model would run. So here you can see there is some progress or processing happening when I hit run the model. And it may take initially few seconds or up to a minute to read all the input parameters that we have defined, and then it is going to run the model, and you would see the progress here. So the progress bar would change from 0 to 100% as the model runs. So let us wait and see how long it takes. And you can see the model has started running now. You see it has, so it is showing the time taken for the model to run, and in brackets it is showing the progress, how much percentage of the simulation has completed so far. So you can see the simulation is progressing up to 12%, more than 12% now. So let us wait until the simulation finishes up to 100%, and then we will see what are the outputs the model is giving us and how we can read those outputs. So the model has finished running. So let us see if we have any outputs. On the right hand side, you can see there is a output tab, and you would see there are some outputs, mean outputs, and then global outputs. Let's see what are the global outputs. So UU represents the velocity, which is the flow velocity, and ZS is the water surface level, and ZB is the bed level. So these are the three parameters that you need to be aware of, which we are interested in. So one is the water depth, which is ZS, and the flow velocity, which is UU, and the bed, how the bed is changing, which is ZB. So in this present simulation, we have not used any bed elevation calculations. So if you see, morphology corresponds to the bed sediment transport, and we have not turned on sediment transport in this simulation. So that is why you would, even though the model has output some ZB, but we would not see the bed to be changing with time. So the bed would be constant because we have not turned on any sediment transport. Okay, now let us see what are the outputs. So if I click on cross shore, let's see what comes up. All right, so this is what you see when I click on the output. And cross shore refers to perpendicular to the shoreline or the perpendicular to the coastline. Along shore refers to along the coastline. And here we are looking at the cross shore. So this is the mean sea level, and we are looking cross shore into the ocean. And this chart is displaying some parameters that you can see. So there is a blue horizontal line, which is the water level, and then this green line is the groundwater level, and then this blue band is the range within which the water level is varying during the simulation. And you can see on the right hand side, whatever has been checked are the parameters that are being displayed. So initial profile refers to this profile of the bed slope. Structure refers to, if we have, let's say if I want to have a building here, then I can also display the structure, but right now we don't have any structures, so I'm going to uncheck that. Run up gauge refers to this blue dot. So run up, as I discussed earlier, it is the vertical elevation up to which the water level can reach above mean sea level. So you would see with time, if the water level is moving up and down, the run up dot or the run up gauge is also moving up and down. And if you would like the water level, then this is the blue line is the water level. So initially at mean sea level, or it is defined at a certain level, and then it would keep moving up and down. And groundwater level is this green line. So here the water level range corresponds to this blue band that you are seeing. So with time the water level is going up and down, and this is the maximum the water level has reached, and this is the minimum the water level has reached. And this is the instantaneous water level. So at any given time, how the water level is across the shoreline, you can visualize. Now you can also create an animation out of this output. So let us say I want to demonstrate an animation. So then what I'm doing here is, in the bottom, you would see initially the cursor. So we are on messages tab. So I'm going to click on time navigator. Here you see some controls where you have a play button, and you can go to the next frame, previous frame, or to the last frame, or to the first frame. And this is the time that you can visualize in seconds. So we have given a duration of 3600 seconds for the model. So you would see 3600 seconds as the maximum time. Now what I'm going to do is to start the animation by clicking on play. And what happens is this water level is going to move up and down. So this blue line is going to move up and down, and so is this green line. So I want you to focus on these two things. Of course, there is also a groundwater level which is going to change. So I'm going to turn off the groundwater level for now, because we are not interested in groundwater level. So once I uncheck this, you would see the green line has disappeared. So I want to focus only on water level and the run-up gauge. So I want you to look how this blue line is moving up and down, and corresponding to this blue line, how this green dot is also moving up and down. So I'm going to click on play here. Okay, so there seems to be an issue. So let's try to continue. Oops, so there is an error and the model has crashed. So let's try it again. So I'm going to open the model because we have already created a model, test one. So I'm going to open this, load this model, uh, choose this, and then I'm going to hit, because we are not changing any parameters, I'm going to hit run. So in the outputs, we don't have any outputs. So we need to run the model first, so that we can visualize the model results. All right, so I'm going to home tab and then click on run. And the model is going to run. Let's wait. All right, so the model has now finished running, and we are going to go to the output. And in the output, we are going to go to the time navigator. And now you would see the time range is only 0 to 360 seconds. That is because of the parameters, we did not change it to 3600. So it has run only for 360 seconds. So we are only going to visualize the results for 360 seconds. Again, I'm going to remove the structure on the right hand side, and I'm also going to remove the groundwater level. So now we are going to focus on the blue water line and the run up gauge. So let's try to run the animation and see. All right, so the animation has started, and you're seeing that the waves are starting to come from the offshore to the near shore. And you would see the run up gauge is moving up and down. So these are the waves that are hitting the ocean, from the ocean onto the beach, and you would see the waves are, the run up is also increasing as the waves are coming to the beach. Right. And now let's see what is in the time series. So in the time series, again, you can choose the, all right. So what you're seeing on the x-axis is time, and what you're seeing on the y-axis is value. So on the y-axis, I'm going to keep only water level, and I'm going to uncheck everything else. So I'm going to uncheck the statistics and mean. So I just want to focus on the water level. And here you would see the cross shore position, which is minus 795. So let us go back to the profile for a minute and let us identify where this location is. All right. So I'm going back to profile. So 795 is somewhere here, which is on the offshore boundary condition. So if I go to time series, what you're seeing here is the water level with respect to time at the ocean boundary. So these are the waves that are coming to us from the ocean boundary. Now, if I move towards the beach, now when the waves come to the beach, you would see they have totally changed in shape, because the waves, when they come to the beach, they start breaking. And this is what breaking waves look like. So each of these peaks represent a single wave event. So these, if you see, they are very steep in the front because they are breaking. And this is with respect to time. Now let us go to run up. What is in the run up? So in the run up, I just want to focus on run up height, and I want to uncheck everything else. So this is how the run-up has been changing with respect to time. So what does this mean? If I go back to cross-shore, so this green dot was originally at the mean sea level, and then with time, this green dot is moving up and down. So that is what we are visualizing here. So the green dot is moving up and down with time. And this is the run-up data. Now you can also export each of these data by right-clicking on it and export. So if I export it, let's say I want to call this run-up, and I'm going to save it. And I also want to store the cross-shore data. So I'm going to say export, and I would say I will go back to my directory where I have my simulation, which is in documents, XBeach, and I'm going to say this cross-shore. So all my cross-shore data is at this location. I'm gonna hit. Now, if I go to this folder where the simulation is, now first I'm going to look at run-up. So here you see the data has been, oops, I'm sorry about this. Let me quickly sign in to Excel. All right, so we have, signed in into Excel. Now, what we are going to do is, you see that all the data is not properly formatted. We need the data to be formatted. So I'm going to select all of this and go to data. Let me save it again. Looks like I don't have license for Excel on this computer, but anyway, let's see what data we have here. So here we are looking for the run-up height R. So if I right click on it and export, all right, so I seem to have some technical issue where I'm not able to open the Excel to process the data. But what I want you to do is to download the software, install the software, and then try running different sets of simulations. So let's say you change the wave height from 3 meters to 4 meters or to 2 meters or 1 meter. And the period also you could change to, let's say, 10 seconds or 15 seconds, and see how the run-up is changing. So this is what I want you to do. Uh, so the profile, probably you can keep it constant, but change the wave conditions and see how the run-up is changing. And then we will discuss the outputs that you get from the simulations in our next meeting. So this is how you can set up and run an XBeach simulation yourself. And I want you to play around with the model so you're comfortable in changing the parameters. And also I want you to read through the web page so that you have a total understanding of what this software is meant for and what it can actually do. So let's have a chat next week more on this.